Hello everyone, and this is Haidar Mahmood. In this video I will explain the image processing assignment for the third semester in Mediology. This is a program that is programmed in C++ with the use of open frameworks with the compiler called Cplspls. So let me go ahead and run through the program first. So you see, this is the program, how it looks. I have the total of 5 images. The first one shows how the camera sees. Then the second one is running through a lot of filters like brighten, darken, grayscale, and so on. Then we have the red, green, and blue passes. These passes are tracking devices where they exclude. If it's, for example, red, they exclude the green and the blue. Then it's still back. We have the red, which I use for the tracking. So first, I will show you the red, green, and blue channels is by assigning the following. I have assigned the following keys, like Shift B. That's the channel. Let's go and turn it off and show the green channel, and then the red channel. So if you combine them, it will go black. So with that being said, let's go ahead and talk about the trackers that I have been working on. So I have a piece of paper that is blue. So you can see in the why I'm so it's a bit hard to you can see in the blue parts that it's appearing, because the reflection might be annoying, but if we, for example, give it a little bit some brightness or make it a little bit darker, then it will appear much better. So let's go ahead and turn on the tracker for the blue pass, which is J. And as you can see, this is the blue tracker, and it tracks the piece of paper very accurately. So you can see the coordinates for the blue tracker, which is the first one is the x-axis and the second one is the y-axis. So with that being said, let's go ahead to the green one. So this is the green. Let's go shut the blue tracker down and activate the green one, which is K. So this is the green. Why is it not showing up? Okay, now it's showing. Good. So this is the green tracker. Bit hard to go. Yes. You can see in the passes they look like this, and you can see also the tracking point. So this tracking point, let's go ahead and move over to the red. So this tracking point goes ahead and calculates the center of the mass of the object, and then put itself in the middle. So shut the green down and turn on the red tracker, which is L. So as you can see in the red pass, it appears to be black and white. The reason why is that it runs an if sentence that says if there's a white red color in the image, then everything should be black, except everything should be grayscaled, where the color red should be white, and everything else is blue. Is black. So you see, this is the code for the program. So I start first with the use of 2 for loops, as seen in the top over here. The first for loop is to store the x pixels on the x-axis in a oops, a little bit, nothing changed here. So I started for the x-axis to be stored in a unsigned in a array that is of type of unsigned char. So and I do the same for the y-axis. I also use a for loop for that. Then I take these for loops and I run through this pixels which is stored inside this arrays. The first one called video inverted, then the second one is called video inverted red, green, and then blue, and as you can see, equals the pixels of the picture. And then I have this filter, and among many others, which you can see is done by subtracting the picture by 255, and same go on with the others. Then I have the channels. For the red channels, what I used is that I have the red channel. I have taking I have filtered out the green and the blue. You can see that red has the value 0, the green and the blue has 1 and 2, which is set equal to 0. So thereby I only pass through the red. I did the same with the green and the blue, which I pass through the 0, and I pass through here through I pass through number 1, and I pass through here number 2. Everything else is zeroed out. For the tracking, I have used this line of code where I, as explained before, I have this equation where there's the red. For example, if we take the red tracker, the red pass, I say red divided by red plus green plus blue, and I compare that, and I plus that to 0.01 in case that the final value of the equation becomes 0, so the program will not crash. So I compare it with a value of 0.55, which is the minimum value of the brightness of the color red, and 120, which is the maximum value of the darkness of the red color. And I do the same with the other colors, but I assign to them different values. You can see, for example, in the green I give it 0.5 and 30. That's because this numbers works better in this case. So moving along to the tracking cross, where I calculate the center of mass. You can see the equation over here, and I have this center of mass going down to the draw area, where I draw 2 lines on top of each other to form a cross with different colors. So I assign this cross, as you can see over here. This is a red color, and then I have used this draw bitmap string to have these coordinates being visible. So now I have been, and this is for the text that I've used within a 14, and yeah, that's pretty much it. It covers almost everything what I had to say. So thank you for watching, and see you next time.